Today's learning target is our last of our exponential properties, at least until later in the week when we have to start using them again, especially two of them. But we're going to be simplifying expressions using all our properties. That means these problems have more than one property to them. Up to this point, we've been just doing product rule one day, quotient rule one day, power of a power rule one day. Today there will be a mixture in our expressions. The thing we got to think about is what order do we want to do these in? And there could be more than one way to solve a problem, but there's probably a better way to solve it and a faster way to solve it than others. But what we're talking about, the type of problem we're looking at is a problem like this where we can see there's more than one rule going on. In fact, this problem right here has all three. Before we move to the next slide, you want to write this problem down. Now you don't want to make it fill up the middle of your page, write it off to the left side of your page because we're going to be simplifying in a little bit. And here's the thing. We still use order of operations to do this. However, these rules will make our lives a little bit easier because on a problem like the one we just saw, you really don't want to raise those numbers to those powers all the time. It takes a while, you'll be asking for a calculator, but every year we've seen this come up on the K-Prep, it's been on the part with no calculator, which means they must be wanting to use these rules down here as well as the -0 power rule. But here's the thing. We see our order of operations here with the exception of addition and subtraction. We kind of leave those alone. We don't apply those to our order of operations when we see that because those are the last two things we'll do. And usually the only time we add or subtract is after we simplify. We then raise our numbers to those powers, our bases to those powers, and add and subtract. So I'll talk more about that in a second. But the first thing you're going to do is parentheses, just like you always do. You're going to simplify inside the parentheses. That means if you see the product rule, you're going to do that. If you see the power rule, you're going to do that. If you see the quotient rule, you're going to do that. If you see a combination, well, this is going to help us right here if you see a combination within the parentheses. Because the thing about it is this is the same order you would go inside the parentheses. So if your entire expression is in parentheses and that's being raised to a power, the first thing you would do is the exponent rule, which the exponent rule down here you would use is this one. You would use the power rule. Then you would multiply, which means which of these would you use? Well, multiply product means an answer to a multiplication problem. You would use the product rule. Then you would divide, which means we would use our quotient rule. Now, if you have parentheses, you would go in this order inside the parentheses. Once you simplify inside the parentheses, though, then you would, if there's no parentheses left over, power rule, product rule, quotient rule, because that's the order of operations for these rules. Once you fully simplify everything, then you would apply your -0 power rule. Now keep in mind, in both the product and the quotient rule, you have to have similar bases. You can't apply those rules to things that don't have similar bases. Now sometimes they'll trick you and they'll try to put like a little subtraction problem inside your parentheses, and if you did that subtraction problem you'd realize that, wait a minute, the answer to this addition or subtraction problem, the thing next to it is a base just like it. So you better be careful with that. But if you notice that you have two bases that are not the same, you can't use these two rules, you can only use them on similar bases. Your addition subtraction steps are done after you finish simplifying. And this is when we actually evaluate. This is going to be evaluated answers. Now, we're going to be doing a lot of practice doing these up here more than doing these down here. You do have an example on your homework assignment from last week. It was number 18, if I do remember correctly, where you did have a couple bases you had to add together, but you couldn't go any further after that. So let's go back to our first example. And it was this right here. So the first thing we're going to do is do whatever's inside the parentheses. Well, the thing inside the parentheses is the product rule, 10 to the third power times 10 to the fourth power, which means since we're multiplying like bases, what are we going to do for the exponents? We're going to add our exponents. So we have 10 still, but 3 plus 4 is 7, so that's really 10 to the 7th power. Now I'm just going to put parentheses around this for one simple reason. We still get this second power on the outside of it that we're going to have to deal with. And that's still all over 10 to the 12th power, meaning it's being divided by 10 to the 12th power. So that's our first step right there. Our first step was simplify within the parentheses. Our next step, are we going to do the quotient rule or the power of power rule, which we have right here? Well, we're going to do the power of power rule because we need to clean up here before we can mess with this 10 to the 12th power. So we're going to do the power of power rule, which means we're going to multiply 7 times 2 to see what that 10 is really to. It's to the 14th power. Then we're going to divide it by 12. 10 to the 12th power, excuse me. So our last step is the quotient rule here because it's nothing else, there's nothing else we can do with this. So since our bases are the same, we're going to have a 10 in our answer, but our exponent's going to be to what power? Well, whatever 14 minus 12 is. And there's our simplified answer. Now the thing about it is, back when before you had these rules in place, you would have used order of operations to solve this problem. That means you would raise 10 to the third power, 10 to the fourth power, multiply them together. Then whatever that came out to be, you would raise that to the second power. Then down here you would raise this to the 12th power before you could divide whatever's on top by what's on the bottom. Why do all that extra work when it's all said and done? All this really is 10 to the second power. And you should know what 10 to the second power is. It's 10 times 10, which is 100. 100 is the value of 10 to the second power. It's the evaluated answer. So let's look at some more examples. I mean, this is why we do this, is just get around having to do a lot of extra work and find out what our expression is really trying to get us to do. So here's two more examples. And this is going to be simple examples. Some of you probably start on it. I'm still going to go over it with you. Our top example, there's no parentheses. There's no power rule. You don't see a power on top of another power. In fact, what we see first is what's on top right here. We see the product rule. So we're going to do that first. We have 5s, like bases, multiply them together. That means we're going to keep our base. What we're going to do to our exponents, we're going to add them. 4 plus 5 is 9. We keep the 5 to the 7th power on the bottom. What rule we're going to do now? The quotient rule. So that means we keep our base since it's the same, so it's 5 to something. 9 minus 7, I'm going to put a little 9 minus 7 right there, is 2. Once again, think about what we have here. You can use order operations to evaluate this thing. Raise that to the 4th power, that to the 5th power, multiply them together, and then divide whatever 5 to the 7th power is, because you're going to have to raise that. Or use your exponential properties or exponential rules to simplify parts of this to see what that problem is really trying to get you to do. Because all of this, when it's all said and done, is just 5 to the 2nd power. And if we're going to evaluate it, we just raise it to the 2nd power. This is an evaluated answer. That's a simplified answer. Simplified just means we're rewriting a problem into a simpler problem. Let's look down here. This example. Same thing's going on. We've got multiple rules going on, but if we notice, we do have parentheses. That's where our attention's going to. But if you notice, it's just 3 to the 3rd power inside. So we don't have to simplify anything on the inside. So we go down to our next step, which is our exponent step. That means we're going to apply our power to the power rule. So we're going to keep our base, and we're going to see what happens when we raise 3 to the 3rd power and then raise that up to the 4th power. And we do that by multiplying our exponents. So 3 times 4 is really 12. So that's really 3 to the 12th power. It's still being multiplied to 3 to the 2nd power, and all of that's still being divided by 3 to the 10th power. Well, here's our next step. What we're going to do next. We see product rule on top, and then we see quotient rule. Well, since multiplication, we have to do some multiplication, I would suggest to do the product rule. Our bases are the same, so what we're going to do to our exponents on top? Add them. 12 plus 2 is 14. That's being divided by 3 to the 10th power. Well, now we can do our quotient rule because we just have one base on top, one base on the bottom that are the same. So what we're going to do to our exponents? Subtract them. 14 minus 10 is really 4. And there's your simplified answer once again. What would you rather do? Raise all those to their powers, and what's inside here, raise it to the 4th power, multiply these two together, and whatever comes out of that, divided by whatever 3 to the 10th power is, or use our product quotient power rule to help us simplify this down to that, which that is much easier to solve than that using order of operations, because here you just got to do your exponent and that's it. So some of you are now asking, Mr. Martin, our examples have had positive exponents. What if we have a negative exponent or 0 power? Well, let's look at this. This one will have that. But we're going to go through our steps like we going to start out. We do see parentheses, but we don't have to clean up any messes inside the parentheses. That's just to the 5th power. So we go down to our exponent step. And we are raising this to the 2nd power. So that means that's 2 to the some power. But what do we do when we have power of a power? We multiply our exponents. That will tell us what that 2 is being raised to. 5 times 2 is 10. So there goes our power of power rule. Now if we look on top, we have the product rule. So I'm going to go ahead and rewrite the top back in. We have a power of power rule. That means same bases. What do we do with the exponents? We keep the base and we add our exponents. 3 plus 4 is 7. That's being divided by 2 to the 10th power. We're back to our quotient rule again. And what we notice is we still got 2 there, here and here. Since we have the same base, what do we do to our exponents here? Subtract them. And this is going to be 7 minus 10, top minus bottom. And 7 minus 10 is not 3, but it's the opposite. It's negative 3. Now here's the thing. Here's our negative exponent. What do we do to simplify a negative exponent? We turn it into a fraction. We flip it over and knock off the negative sign. This is simplified. This is really what that will lead you to. In fact, if you actually did raise all that to their powers, eventually you would come across an answer, and that answer is 1 over whatever 2 to the 3rd power is. And remember, 2 to the 3rd power is 2 times 2 times 2, which is 8. So all of that is just 1/8. This is an evaluated answer. Simplify just means we're rewriting into a simpler problem. Evaluate means you actually take that last step and evaluate your answer. Now when you come into class on Monday or Tuesday when we cover this, what we're going to do is there's one more example I'm going to show you in class, but it's going to be with that addition subtraction step. So if I go back, it's down here and what we do when we see this come up. The thing about it is there's no rule for addition subtraction, so when we're simplifying all the way down, anytime we see a plus minus sign, we got to treat it almost like a barrier. What's on one side we can't do on the other side. So I'll put up an example on the board on Monday or Tuesday and show you what happens with that and how you deal with that. I hope you found this useful, and I hope you have a good day or evening.